Let's talk about algebra word problems. You know the feeling, right? Your eyes glaze over, you see a bunch of words, a few numbers, and you're supposed to magically turn it all into an equation. It feels impossible, frustrating even. But what if I told you it's not magic? It's a system, a code. And today, we are going to crack that code together.
So here's our game plan for today. First, we'll get into why these problems are so tough in the first place. Then, I'm going to show you a classic 4-step plan that works like a master key. We'll break down every step, solve a basic problem, then level up to a trickier one, and finally, we'll see how this is way more than just a math skill. All right? Ready? Let's dive in.
Okay, first things first. If you have ever felt totally stumped by a word problem, you are in very, very good company. There's a real reason they feel like such a hurdle.
And the research backs this up. See, the struggle usually isn't about the math itself. It's about the language. It's basically a translation problem. You're trying to read in English, but you have to write the answer in a completely different language, the language of algebra.
If that sounds familiar, then you're in exactly the right place. Because fixing this isn't about suddenly becoming a math whiz. It's about having a solid strategy you can rely on every single time.
And this strategy, it's not some new fad. It is a powerful, time-tested framework that has been helping people solve problems for a very long time.
Everybody, meet George Polya. Way back in 1945, this guy literally wrote the book on how to solve problems. And get this, his method is so good, it's still considered the gold standard today, not just for math, but for tackling all sorts of challenges.
And this is it. This is the whole secret. Just 4 simple common sense steps. First, you understand the problem. Then you make a plan. Then you carry out that plan, and finally, you look back and check your work. It seems almost too simple, but the real power is in actually following the structure.
We're going to start with what is, without a doubt, the most important step of all, understanding the problem. This is where we stop letting the words scare us and start acting like code breakers.
Okay, this chart right here, this is your secret weapon. Seriously, think of it like your own personal translation dictionary. When you see a phrase like more than, you know, bam, that means addition. You see the word product, that's multiplication. And a simple word like is, well, that just means equals. Suddenly, it's not about guessing anymore. It's about decoding the clues.
And to make sure we've really understood it, Polya said we should ask ourselves some simple but really powerful questions. Like, can you say the problem back in your own words? What is the question actually asking you to find? These things force you to slow down and really connect with the problem before you even think about touching a number.
All right, theory is great and all, but let's see how this actually works. We're going to take our new 4-step plan and put it to work on a real classic word problem.
Here's our first challenge, straight out of a math textbook. 12 more than a number is 17. Looks simple enough, which makes it perfect for seeing our system in action. We've just read it, so step 1 is already in motion.
Okay, let's start decoding. We're scanning for those keywords, and there's one right there, more than. A quick glance at our chart tells us that means we're dealing with addition. Easy enough.
Next up, what's the mystery here? The problem says a number. In the world of algebra, that's our big signal to use a variable. We'll just call it x. So x is the thing we're trying to find.
And the final piece of the puzzle is that tiny little word is. Our trusty chart tells us that's the glue holding the equation together. It just means equals. We have all the parts we need.
So now we move on to step 2, devise a plan. And check this out. Because we did step 1 so carefully, the plan practically writes itself. 12 more than a number becomes x plus 12. Is 17 becomes equals 17. Our plan is simple. Solve the equation x plus 12 equals 17.
And now for step 3, carry out the plan. This is where we just do the math. We want to get x by itself, right? So we do the opposite of adding 12. We subtract 12 from both sides of the equation. And just like that, we get our answer. X equals 5.
But hold on, we are not done yet. Step 4, look back, is so important. Don't ever skip it. We take our answer 5 and plug it back into the original sentence. Is 12 more than 5? 17? Well, 5 plus 12 is 17. Yes, it works. That little check tells us we nailed it.
Okay, that was a pretty good warm-up. But I know what you might be thinking. Sure, it works on the easy problems. So, does the 4-step plan hold up when things get a little more complicated? Let's find out with a classic age problem.
All right, here we go. Alan is 5 years older than Bert. In 3 years, Alan's age will be twice Bert's. How old are they now? Whoa, this one feels like it has a lot more moving parts. But this is exactly where step 2, devising a plan, becomes your best friend. A great plan here is to organize all this info. A simple table like this one cuts right through the chaos. We'll say Bert's age is X, which means Alan's is X plus 5. Then we figure out their ages in 3 years.
Now look how easy that table makes it to build the equation. We just translate the last sentence. Alan's future age, which is X plus 8, times will be, that's our equal sign, twice Bert's future age, which is 2 times X plus 3. And there's our equation. So for step 3, we solve it. Distribute that 2 on the right, you get X plus 8 equals 2X plus 6. Move the X's to one side, the numbers to the other, and we find X equals 2. So Bert is 2. That means Alan is 7. But are we done? Nope. Step 4, look back. In 3 years, Bert will be 5 and Alan will be 10. Is 10 twice 5? Yes, it is. This system worked perfectly.
So we've decoded words, we've solved for X, we've tackled some tricky problems. But I want you to zoom out with me for a second, because what you've just been practicing is so much bigger than just algebra. This 4-step framework, it's a blueprint for how to think. It's a method you can use for any messy, confusing, real-world challenge, whether you're trying to figure out a budget, plan a project, or even just make a tough decision. You understand the situation, you make a plan, you act on it, and you check the results. It's not a math trick, it's a life skill. You might have come here today just wanting to learn how to solve word problems, but what you're really leaving with is a kind of superpower, a universal system for solving any problem. You now have a tool to bring order to chaos. So my only question for you is, what problem are you going to solve with it next?